in some countries, it's absolutely yes. And we enjoy this amazing view with a lot of factories actually.
Yes, we have.
Yes.
We have a beautiful country and we have a really beautiful day here today.
Oh yes.
Yes.
I was thinking about SEIIA also, you know, in southern part you say SEIIA, and we go up to Stockholm, you say SEIIA. Yes, and here we say SEIIA. I've heard another SEIIA, and I don't know how you pronounce it, but the board and the association, do we have a presentation?
Yes, of course. Speaking about that, we have a really good presentation of us, the board members, that we're going to run right now to introduce us to the Industrial Interoperability Summit 2021. So let's go. Thank you.
Welcome to our first online Industrial Interoperability Summit 2021. The agenda today is like this. We start with a short presentation of SEIIA and our board, and then we continue with our pilots. We have a lunch break, and then we have our presentations from European Spallation Source, Alan Johnston, Nils, and Arto from Finland, and we end with Per-Erik Martinsson from Luleå Technical University. SEIIA, Swedish Industrial Interoperability Association, is a rather new organization. We was founded 2019. The board of SEIIA contains on the following people. We have Jonny Sundström from Stora Enso as a chairman of the board of SEIIA. We have Andres Dingvall Rauchberg from VSP as a member. We have Bo Ottosson from Siemens. We have Mats Larsson from Holmen. And we have Mattias O'Nils from Mid Sweden University. We have Niklas Norén from Preem. And we have Roger Jongling from Plan B. And Martin Björlmalm from ABB. And we have Therese Treutiger from Microsoft. And Walter Jonasson from Vakin. Malin Nerpin from Boliden, and Stefan Malmsten from Neuron. What is SEIIA? It's a non-profit association for increasing the understanding of interoperability in industry information handover, and we want to adopt international standards and best practice to be used in Sweden. And we also want to participate in the international standardization and have a return of Swedish know-how back to the global development of standards. So it's a give and take there. Maybe some of you haven't heard about the word interoperability before. But if you go to Wikipedia and give the explanation there, you could read that it is the ability of different systems, often in computer context, to work together and be able to communicate with each other. And that's the main goal for SEIIA to work with. Fundamentals in SEIIA. One thing is that we don't want to invent any new wheels. There are very much wheels running around the world with good initiatives and standards and concepts that have been developed in different type of business around the world that we want to adopt instead of develop something new. Some other thing is that we want, this is a global question or issue. Interoperability is not, you can't work with interoperability on a local, national, or even site level. You need to use international standardization and international concept for that type of purpose. And the third thing is that we need to be open. This type of issues and problems that we have in our industry is much depending on that we have closed systems that are not open to communicate in a standardized way with each other. So we are not marketing proprietary systems because we want to have open open strategies in what we are working with. The SEIIA organization contains of the SEIIA board that we have present recently, and then we also have the SEIIA operations that contains of me and Matti Toikanen as right now. Show me the money. Why interoperability? Yeah, there is solid evidence that the industry have costs for poor handover up to 4% of the total cost for a project. Another investigation that have take out figures that it's about 40 to 60% of maintenance engineers put their time off looking for information and validating it. If you put that figures into your business, how much could you earn? We are very convinced that there's lots of money in digitalization and higher interoperability. SEIIA does not work alone. As we said before, the international networks and participating in international standardization initiatives is a very important thing for the work we are doing. And this is some of the organizations that we are working with on an international base, all of them non-profit organizations. LCDM Phase 2. The project goals have been to increase the competence building in our industry, to start 4 pilots as a major activity to really increase the knowledge about interoperability in our industry. And we want to support the industry and companies with knowledge about this type of questions and issues. And we also wanted to increase the cooperation on an international base. We want to sign international cooperation agreement. And as we are doing right now, hold an industrial interoperability summit. This picture is showing the members we have right now in SEIIA. To all Swedish companies which have not been members yet, support SEIIA and become a member. Help Swedish industry to increase the interoperability and go for digitalization.
So today, one of the most important things is to write down questions. And it will be totally anonymous, so write a lot of questions because it will be a lot of information.
Yes, of course. So let's just say, Lou, don't hesitate to put any questions. We'll be pleased if you take questions to us and you keep your anonymous. And we will read up all the questions and put them. So please do that.
And from the beginning, it might seem for some people complicated like this one. And I was thinking that in the end of this online webinar, it will be crystal clear. And hopefully we will write the vision, because I heard, Sweden was 20 years behind.
Yeah, it might be. The Swedish industry is behind. If you look over the world, and as Erik said in the presentation earlier, it's the work in SEIIA isn't about inventing new ideas. It's to look around you, see what you can get, and apply it on your own company or on your own branch. I think that the one that they show us just right now is quite significant how it works. Put things together and make it work.
Yes, and as a Swede, I know when they get it, boom, action. Yeah.
Yes. That takes us to the next about try and sometimes fail and try again. We have some pilots that we want to present to you.
Yes. And the first pilot is Stora Enso and Dexby. And they will have the time now from to 10:50. So please have your notepads and write down questions. The more questions, the more answers you will have, because we have the competence here.
Yes. So let's see how pilot 1 has done. Welcome, Stora Enso.
Hi, it's now time for our first presentation of our pilots in LCD and Phase 2 project. The first one is done at Stora Enso board mill and based on Dexby. In this pilot, we tried to run different type of systems and exchange information on the Dexby standard. Participating companies are Stora Enso, Symmetry, AFRY, and partly SST. The deliverables are exchanging information between different parties, use the validation tool for Dexby, and also make an analysis of the existing guidelines in SST. I will now welcome Johnny Sundström to start this presentation. Welcome, Johnny.
My name is Johnny Sundström and I work as a manager for the plant data department at Fors Mill. I've also worked as a coordinator for plant design tools and solutions for almost 30 years. I want to start by giving some background on why this project is so important for us. Since the early 90s, Stora Enso mills in Sweden used EDOC plant design system. We also used AutoCAD and EDOC process application for tests used there. Current status. Yeah, for the past 50 years, we have only required process flow diagrams to be drawn graphically according to SSG standards. And because of that, other symbols have came in from various parties. We have at least 4 different symbol sets today, as we know. They all follow the same graphical SSG standards. They have different tag configuration due to different software manufacturers. And they occur mixed in the existing process flow diagrams. It's not possible to handle the information in an easy way. We have graphics and part of the technical information in the drawing, and the rest in several lists. Yes, we need a new way of working, and the idea was born in 2019 when someone said, "Shall we do a DEXP project together?" At Stora Enso, we started thinking about what we need to learn so we can understand what we should do. We understood that most of the software manufacturers in plant engineering already work with established standards and open concepts. We need to learn which standards affect us in the work. We need to learn how DEXP works. We need to learn which SSG standards need to be harmonized to be useful. We need to learn how information exchange works. We need to learn what increased interoperability means. Because it's a very important step towards digitization of process plants. And last but not least, how should we handle existing flowchart diagrams that contains valuable information? Now to the pilot ID and the scenarios. We decided to choose an ongoing project with a suitable scope. We had a breakdown on the partition wall in the existing tank, and the solution was to build another tank including necessary equipment. And as I mentioned before, the process flow diagrams was designed with EDOC process application for AutoCAD and symbols according to SSG standards. And now we wanted a flowchart diagram based on established standards and concepts, which should be easier to handle by all parties involved in the project. And here we have the process flow diagram of the project. We have the existing equipment in the top of the drawing, and here we have the extension. We have the tank, we have a pump, and a blow machine, and of course pipes and valves. We selected the process objects for the tests. We also created a document describing data content, the rules, object properties, units, and DEXP component classes. And we also included the relation between symbols and standards. We also created 3 test scenarios. And we also realized that the technology makes it possible to draw with one standard and recreate the drawing with another standard if the standards are harmonized.
Hello everyone, my name is Janne Ujärvi and I'm working as an application engineer at Symmetry. I will in this section go through a little bit how we interpreted and converted customer requirements according to the DXP specification. As we already heard in the previous section done by Jonny Sundström, we started this pilot work by finding out what customer requirements the plant owner have for the PNID delivery. In this pilot project, Stora Enso Fors is the plant owner and will be referred to as the customer. In this case, the customer wants to use SSG symbols on the PNIDs. To be able to swap symbols during the import-export, we investigated the difference between ISO symbols and SSG symbols. In the next step, we started out to match customer data requirements against the DXP data model and attributes. We start by taking a quick look at the symbol graphics. We found out pretty quick that the SSG symbols is based on the ISO symbols for most part, even if the paper and forest industry have lots of unique symbols in addition. One scenario in the pilot was to swap the symbols during the import and export process. Swapping symbols is absolutely doable with the export-import function for the AutoCAD PNID as long as size of the symbols is the same. Unfortunately, SSG and ISO have different sizes for many types of symbols. The size mismatch will cause connection problems between symbols and lines. The DXP specification includes lots of DXP data attributes. Some of these DXP attributes is easy to match according to the customer requirements. But a lot of the required data attributes need to be handled or transferred as custom attributes. To set up and define custom attributes is pretty easy task. The challenge is to add them to the right hierarchical level, especially when you have different type of PNID systems trying to work together. In the following examples, I will try to show you some of the challenges with defining custom attributes for a pipeline and other type of objects. We see this short list of customer requirements, just 7 of them. We managed to map 4 of these customer required attributes to the DXP attributes. 3 attributes need to be specified as custom attributes. If we now break down the pipeline into the different hierarchy levels in the DXP data model, we can see that some of these attributes belongs to the piping network system and some of them belongs to the piping network segment. The hierarchy structure suits the PNID application I work with pretty well, the AutoCAD PNID from Autodesk. But these custom.
Hi, it's now time for our first presentation of our pilots in LCD and Phase 2 project. The first one is done at Stora Enso board mill and based on DXP. In this pilot, we tried to run different type of systems and exchange information on the DXP standard. Participating companies are Stora Enso, Symmetry, AFRY and partly SSG. The deliverables are exchanging information between different parties, use the validation tool for DXP and also make an analysis of the existing guidelines in SSG. I will now welcome Jonny Sundström to start this presentation. Welcome, Jonny.
My name is Jonny Sundström and I work as a manager for the plant data department at Fors Mill. I have also worked as a coordinator for plant design tools at the Swedish mills for almost 30 years. I want to start by giving some background on why this project is so important for us. Since the early 90s, the Stora Enso mills in Sweden used EDOC plant design system. And we also used AutoCAD and EDOC process application according to SSG standards for the process flow diagrams. At that time, EDOC was widespread in Sweden and most of the users, plant owners and consultants, used the application. Unfortunately, EDOC was not used for more than document management in Stora Enso, and it was replaced in 2005 by SAP DMS, and the drawings was created with AutoCAD and a symbol library according to SSG standards. And what does that mean? We still followed a graphical standard, but no one reflected on the technology behind it. We suddenly had two different symbol sets, and several came quickly, I will say. Current status. Yeah, for the past 15 years, we have only required process flow diagrams to be drawn graphically according to SSG standards. And because of that, other symbols have came in from various parties. We have at least 4 different symbol sets today, as we know. They all follow the same graphical SSG standards. They have different tag configuration due to different software manufacturers. And they occur mixed in the existing process flow diagrams. It's not possible to handle the information in an easy way. We have graphics and part of the technical information in the drawing, and the rest in several lists. Yes, we need a new way of working, and the idea was born in 2019 when someone said, "Shall we do a Dexby project together?" At Stora Enso we started thinking about what we need to learn so we can understand what we should do. We understood that most of the software manufacturers in plant engineering already work with established standards and open concepts. We need to learn which standards affect us in the work. We need to learn how Dexby works. We need to learn which SSG standards need to be harmonized to be useful. We need to learn how information exchange works. And we need to learn what increased interoperability means. Because it's a very important step towards digitization of process plants. And last but not least, how should we handle existing flowchart diagrams that contains valuable information? And now to the pilot ID and the scenarios. We decided to choose an ongoing project with a suitable scope. We had a breakdown on the partition wall in the existing tank, and the solution was to build another tank including necessary equipment. And as I mentioned before, the process flow diagrams was designed with EDOC process application for AutoCAD and symbols according to SSG standards. And now we wanted a flowchart diagram based on established standards and concepts, which should be easier to handle by all parties involved in the project. And here we have the process flow diagram of the project. We have the existing equipment in the top of the drawing, and here we have the extension. We have the tank, we have a pump and a blow machine, and of course pipes and valves. And we selected the process objects for the tests. We also created a document describing data content, the rules, object properties, units, and DEXB component classes. And we also included the relation between symbols and standards. We also created 3 test scenarios. And we also realized that the technology makes it possible to draw with one standard and recreate the drawing with another standard if the standards are harmonized.
Hello everyone, my name is Janne Joujärvi and I'm working as an application engineer at Symmetry. I will in this section go through a little bit how we interpreted and converted customer requirements according to the DEXB specification. As we already heard in the previous section done by Jonny Sundström, we started this pilot work by finding out what customer requirements the plant owner have for the PNID delivery. In this pilot project, Stora Enso Fors is the plant owner and will be referred to as the customer. In this case, the customer wants to use SSG symbols on the PNIDs. To be able to swap symbols during the import-export, we investigated the difference between ISO symbols and SSG symbols. In the next step, we started out to match customer data requirements against the DEXB data model and attributes. We start by taking a quick look at the symbol graphics. We found out pretty quick that the SSG symbols is based on the ISO symbols for most part, even if the paper and forest industry have lots of unique symbols in addition. One scenario in the pilot was to swap the symbols during the import and export process. Swapping symbols is absolutely doable with the export-import function for the AutoCAD PNID as long as size of the symbols is the same. Unfortunately, SSG and ISO have different sizes for many types of symbols. The size mismatch will cause connection problems between symbols and lines. The DEXB specification includes lots of DEXB data attributes. Some of these DEXB attributes is easy to match according to the customer requirements. But a lot of the required data attributes need to be handled or transferred as custom attributes. To set up and define custom attributes is pretty easy task. The challenge is to add them to the right hierarchical level, especially when you have different type of PNID systems trying to work together. In the following examples, I will try to show you some of the challenges with defining custom attributes for a pipeline and other type of objects. We see this short list of customer requirements, just 7 of them. We managed to map 4 of these customer required attributes to the DEXP attributes. 3 attributes need to be specified as custom attributes. If we now break down the pipeline into the different hierarchy levels in the DEXP data model, we can see that some of these attributes belongs to the piping network system and some of them belongs to the piping network segment. The hierarchy structure suits the PNID application I work with pretty well, the AutoCAD PNID from Autodesk. But these custom attributes we want to add could belong to the piping network system as well as the segment. So in this case, we add them to the piping network system level, and then we need to describe this in some kind of framework document for the project. Because if you don't create any framework document with the detail level, with the right detail level, you could not expect to receive a file with attributes in correct place or data attributes at all. We take a quick look at the pump object also. The pump object is a little bit more complex in the data model. We still have the same amount of attributes, but we can see in the far right column that there is more attribute owners for the pump. The pump object itself will have connections to both subparts as chambers and nozzles, and also to the parent objects, tagged plant items and equipment. Also, in this case, we have 3 data attributes that couldn't be mapped straight away to an existing DEXP attribute, so we need to add 3 custom attributes. So, which of these objects should be custom attribute owners? Yeah, will it be the pump object, or the equipment object, or the tagged plant item, or one of the subparts, chamber or nozzle? In this case, it's pretty obvious that the additional flow levels should be added to the pump object. But the service is a little bit more tricky because DEXP doesn't specify any service attribute to an equipment object at any level. The flexibility with the custom attributes gives us the opportunity to meet the customer requirements as long as we add them to the correct level and that all parties in the project agrees and understand how to handle them. And this work with the custom attributes will be the same for every single object type. If it's an equipment or valve or instrumentation or overlaying hierarchies like the plant structure information. Work with the framework document will be the first step in a DEXP-based project. When you set up this framework, you need to take in consideration that what systems will be involved in the project and how do you interpret the customer requirements according to the DEXP structure. Now we'll take a look at some short recordings from this pilot. In this video, we have finished the work with creating the framework. So now it's time to set up the engineering system. In this video, we are exporting one small part of the PNID to a neutral DEXP XML file. I will also run it through the verificator before sending it to AFRY for further work on the process design. This video will show how it looks like to bring in the DEXP file at the AFRY end of this test circuit. In this last video, we will see how it looks like when we receive that DEXP file from AFRY again. We start by running it through the verificator and then import it into our PNID system. Here is some of my conclusions as a pilot project member. We have already seen this concept been proven by the DEXP organization and also the prior pilots. But the main target for this pilot was to try it out and try the usability in a real ongoing project. The first thing I recognized was the flexibility the DEXP specification gives you for both handling the graphics and also the flexibility in the data transfer. The flexibility for customization is important to be able to meet the requirements from plant owners, but it also highlights how important the work with the framework document is. The framework need to be very detailed and complete before any design work starts. To convert the customer requirements to DEXP compliant framework will require both depth knowledge of the DEXP data model. You will also need to have a knowledge of the involved systems because they are treating the hierarchy levels a little bit different, and also the export-import functionality will be treated a little bit differently. To create this framework from scratch is really a time-consuming task. Hopefully in the future, both plant owners and engineering companies will align engineering data according to an international standard. But in this transition period, I think we need an industry-specific framework as base plate to start from. Even if you manage to create a detailed framework, you will always have some issues with the import and export from different systems and tools. This troubleshooting is also time-consuming and difficult because, as you could see in the last video, the verification tool actually gives you a satisfying result, but the receiving system doesn't read the file as good.
We have also considered which established standards affect us in the work and the relationship to the SSG standards. And a quick reflection on this then. ISO 10628 Part 1, which is named Specification of Diagrams. We can say that's the drawing rules that's missing in SSG, I will say. And if we talk about the Part 2, which is the graphical symbols, we can say that in general ISO contains many more symbols, but SSG has some industry-specific symbols and solutions. And what have we found regarding the SSG standards then? Yeah, I think it needs to be clarified what information level the process flow diagrams intends to have if you follow the SSG 5270 standard. Is it a flow chart or a PNID? SSG, the SSG standard also must be harmonized with ISO. And it must be available as a complement to the forest industry. We also have seen that we need a guideline defining the data content of the diagrams, both the data to be represented in the diagram, the graphics, and also the hidden attribute data. And now some conclusions. We need a framework that describes and meet at least the legal requirements. And my suggestion is also that the standardized companies, SSG and PSK, together with the non-profit organizations, THTH and SEIIA, the four parties should together with the industry develop a framework for the process industry. Because the process industry needs an open format for the exchange of plant information that can carry more than only the graphical symbols. We need to keep the information quality and have an easier way of handling this information between all involved parties. And finally, it has been a successful project because we have found some really important topics, and hopefully it will be useful in the continued work.
So welcome back and thank you for that. We have some questions.
Yes.
Yes.
I love questions.
Yes.
Especially when I know them. Yeah.
To get a good question is about to know the answer. Huh?
Oh yeah.
But we can start with the easy one.
Easy one.
Easy one. Which city do we have in the background? It's quite white outside. Maybe you see something through it.
It's actually in the 1880s. This was the world head capital when it's coming delivering timber around the world. It will look amazingly. And if you go a little bit to the right in the picture, behind there, you can see a second bridge to the world famous Alnö. And Alnö is an island. And when I say world famous, it's actually a unique island because it's the only island in the whole world who has a mountain species named after it. And that's the famous Alnöit. It was not until 1956 they also found it in Congo. And surprises that, wow, Alnöit. Yeah. So this is a nice place, and hopefully one day you will come here, enjoy, because we have two mountains, Northern Mountain, the Southern Mountains, as we are now. So it's, well, you have nature and you have factories.
Yes, what you also see in the background is the plant of SEIIA that we used to zoom in.
One of them.
One of them.
Yeah.
One of them, I said.
Also,
yes. So the answer on the question is Sundsvall.
Sundsvall.
As simple as it is.
Yes.
It's your city. Yeah. Another question, will the presentations be available for participants? And that, of course, it will be, everything will be recorded and will be possible to see it afterwards.
Yeah. And one person wrote, Swedish industry 20 years behind, as we said. Actually, if it should be pinpointed, it's when it comes to this. Swedish is known to be ahead of a lot of things.
Yes.
But you can develop it more,
20 is maybe much time, but what we speak about and the main ideas of SEIIA is that to look around in the world, in the world, see solutions and apply it back home. And it's not that we are behind someone else. I think we can take some pieces from every country and from every industry, and that makes us stronger. It's all about to put things together.
Yeah. And
maybe you can put things together that's broken.
Well,
Sometimes.
it's like we talked before, and I said, you know more about this than I, and it's like the guys here because it's a lot of technique here, man. And I was thinking of this with like an elastic. If this snaps, it's broken. But if you have good technicians, you can actually mend it. Can you see, Mats?
Yeah,
Mend
but you keep your things there.
Oh, no, it's mended. So perhaps today we will have some issues with the technique, but we have the competence here, so we will figure it out.
Yes, and as we said before, we had some technical issues.
Yep.
With the level of the sound.
All the chords here, we just move. We can move here, and otherwise it's like zillions of stuff.
Yes.
But you can move whenever you want, because when you listen to these speakers, it's a lot of information. So stand up and relax, move. Very important between, because we are soon ready for the pilot 2.
Yes, and that takes us to the factory actually that we shown before. It's the company SEIIA.
Yeah.
That together with the Chiefos concept have made the pilot number 2. So can we?
Oh yes, I think so.
Can we check with the technical?
Yes.
Are we ready for broadcasting the pilot 2?
Boss, is it ready? Yeah. Eric has to be. I mean, he's like he needed 2 more hands, and this is a kind of new technology.
Yes, it is.
And I always say, if it's any positive with this pandemic, that we are forced to use this like in a normal situation way. So in the future, even if the pandemic is gone, I think this will be like saving time, saving money, even if it's more fun to shake a hand. And we can actually shake the hand in spite the pandemic. If you want to know more, write a question.
Yes. Yeah, and speak about that, Love. Looking into the future, even if we hope and the ambition is to have the next convent next year that we're going to make it physics.
Yep.
I think still we're going to make some kind of broadcasting digital anyway.
Yeah.
Because I think this technique is here to stay.
Yes.
And we have to adopt it.
Yeah.
And also that is, you can make the similarity to the SEIIA work.
Yeah.
You find new techniques, you
Yes.
adopt it, and you use it. So I think that's a comparison.
So Eric has he has a new color of his hair, gray hair, technique. No, even if you have been around this for a long time, me, I've been reading, watching, and it's like, wow, why was Sweden so behind? Because it was started in England, right?
Yeah, a lot of this, we have a lot of places that it started up, and England is one of them. And also to our friends in Norway, they are quite ahead of us, thinking about the oil and gas industry.
Yeah.
They have used this kind of ideas and work with it longer than we have did. You can also see that SEIIA is quite newborn. We are still young.
Yeah.
Not maybe you and I standing here, but as a
when the Swedes say yeah, it means like you can't find the English word.
Exactly. Exactly.
Yes. So Eric has gone from this to this now. That means like.
Can we get the pilot 2 in the picture? Things are moving.
By the way, the water we have here in our taps is actually one of the best in whole Sweden. And it's sad when I buy water in a can in America, I say, we flush our toilets with better water than this. And that's a bit sad, when you have too much of something, it's sad, because it's like really,
Enjoy.
It was not water.
That's for later on.
No. Erik?
Do we have any more questions? Let's take a look.
Okay.
And now I got my /ready. That means that we say welcome to pilot number 2, the SEIIA and the GFOS concept. Thank you.
Hello, this is Eric Molin at SEIIA, and today we are going to present the LCDM phase 2 projects pilot, and now I come to the SEIIA pilot based on CFOS. I'm going to present today the 7th of March 2001. The SEIIA pilot have these deliverables. This text was written when we started this project, so we have been some changes during the project, but the participating companies and organizations is SEIIA, the pulp and paper industry company in Sweden, and we have SSG, Standard Solution Group, who's working with spare part database and also with invoicing contracts for handling projects. And we also have a Eurocon site base, which are engineering solution for plants in mostly in Sweden. And the deliverables we have in this project is to create an exchange experience of how we could make a digital requirement process handover process based on CFOS and ISO 59206. And also we have in this we have an analysis of how SSG could in the future maybe support this type of initiatives in their product database and also in a delivery contract. The base on that we have done this project is that we have made up a MOU with EOGP and CFOS between SEIIA and EOGP. So in this MOU we have our agreement that we could base Swedish solution on the CFOS concept and standard, and that's what we are trying to do now in this pilot, and we also will show some conclusion of it later. So Johnny, you have seen some challenges.
Yes, hello. Yes, during the Helios project we had at SEIIA Östrand, we required the suppliers to use an Excel template to fill in the data, for example, for pumps and valves. And then we used this template to import the data into Sitebase. We have had some problems with the suppliers not filling out in the right information in the right place in this template, and it has meant some extra work for us to correct it.
Thank you, Johnny. Then we continue and have a short description of what CFOS is. For you who we haven't been in contact with CFOS yet, we could say that it's based on two parts. We have this graphic part, which also are data. You can describe it also in a data format, but this is easy for us to understand when you have a graphic model. But this is the equipment data model, you could say. This CFOS is based on two base things, that you have a tag class, the object part of the object definition of the tag, and you also have an equipment class property. So you have relations between the tag and the equipment, and when you talk about industry data, you need to separate the functional part and the equipment part, or the component part. So that's the data model, which are the base for this concept and standard. And on the other part, we have the data, what do you say, the reference catalog, which contains of lots of CFOS references. So each description or each property in the CFOS concept have a unique ID that you could use for identifying the same type of attributes depending on its, if it's on the tag or if it's on the equipment. And that's this data, what you say, data warehouse in some way, you can say, that we have used for our pilot when we have done our tests in this pilot. But if you go back a little bit in what's happening in Sweden and where are we now? As Johnny told us, we have the Helios project that have been using this type of templates for their project, and with success they have getting data and that's working fine. But it's specially designed for this two systems, the site-based and the ERP system that SEIIA have. It's the same if you go to another company, Rottneros, they have this almost the same templates. They are based on import data to IFS systems. In Holmen, they also use IFS and other systems, so they have their templates. Stora Enso is another big company in Sweden in pulp and paper industry, and they have their templates. And we have another company in north part of Sweden, which are a wastewater treatment plant and Wakin, and they have their templates. And the pity is that these templates are unique. Each company have their unique templates, and that's one of the issues that we wanted to look at in this pilot, to see could we set up a industry template instead of having these different company unique templates. And also what we think is a very good for the first step for us to take is to all of this is done in Excel templates. Both CFOS and this company unique templates are made in the same system as Excel templates or Excel sheets. So that's why we don't have to change the way of working. We could do the same as we do today, but we have a more standardized templates instead. So this is what we have done. We have started the project and we have used the SEIIA template for pumps. And instead of the old references for importing to the site-based system, we have used CFOS keys instead. So for example, you see here the green parts are functional data and the yellow parts are equipment or component data. So we have found out that most of the data we have, the SEIIA have in their standard specification, we could use CFOS for. So that's why that's the conclusion we have done in this project, that we could use the same template as we have SEIIA have done used in their Helios project, and we could just put in one more row in the template, and we have a CFOS specified template instead. So now we're going to see Thomas Ober at SiteBase going to show us how you could use this special made CFOS template based on the SEIIA template could be imported to the SiteBase system as a standardized template. So I welcome you, Thomas Ober, to the scene.
We open the Excel file, we can see that on row 11 in the Excel sheet we have the CFOS field mappings. Example here for description field beskrivning, that is here mapped to CFOS 10177. In SiteBase, we have a user configured mapping for the CFOS field, and here we can see that CFOS 10177 is mapped to a temporary variable beskriven that is then used in the SiteBase web API. In the SiteBase web API, then we can see that beskriven, if we look here in the web API definition, we can see that this variable beskriven is mapped to the SiteBase database field description A. So the import is made in two steps, first from the Excel sheet, which is read with the script, and then the SiteBase web API is called with those values that are then sent to the SiteBase database. We put a remark CFOS imported in the remark field, so we search for that now to see if we have any object that has CFOS in the remark field. Looks empty, no result, so we have to run the import script. And now Murphy showed his ugly face because the Excel file was open, so it got locked, so we have to close that. And here we can see some output of what it reads, and there are some debug prompts that comes to the screen. And if you have good eyes, you can recognize some data from the Excel sheet. We do some test connection and do some test with the SiteBase web API. That is what connects to the SiteBase database. We try to import the 4 rows as pump functions. Actually, 1 row in the Excel sheet is 2 rows in the database, a function and a component. So it's done and says that we should verify in the SiteBase database to see what has happened or not happened. And as you can see, we have 4 rows with pump functions that come from the Excel sheet. But now still remaining is the import of the pump components that are what SEIIA draws in the PIN-ID schematic. And those also have a suffix of -001. So we try to import the pump components from the Excel sheet as well. And we have some data output to the screen for each pump component sent to the SiteBase database. So it's done. It says we should verify in SiteBase. And now we have 8 objects that have this CFOS remark. And we go into the object detail for this pump function, the 211 PU 9101 with description råvattenpump 1, raw water pump 1. You can see the tooltip says description A, the database field we had in the web API mapping from before. We go back and look in the Excel file again. We can see that we have the correct tag number 9101. And we have the correct description, råvattenpump 1. Looks to be correct as well. We have some properties, for instance, flow normal or flödenormal in Swedish, and some other properties as well. And since it's a green Seafulls field, they are put to the function object. We've got a value of 3200. So we verify to see if that's the value in the Excel sheet. We have to zoom in to see that properly. And here we can see we have 3200, so it's made correct import and update of that property. The import script is made in C#. It reads the Excel file, sends data to site-based web API that communicates with the site-based database and creates the objects and update the properties in the database. And the mapping is mainly done by the user in the site-based system in these forms. And as the example, we can see here that the 177 CFOS field goes to the description with the temporary variable between that was called beskriven that goes to the site-based web API. And one specific thing here is that in site-based the tag number is divided in separate fields. It's not one long string. So we have to divide it up in separate fields, and that is done in this mapping as well. And I guess that's about it in this import.
Okay, thank you, Thomas. And then we're going to continue to look at what SSG have done, and Patrik Kallhammar.
Hello, my name is Patrick and I work at SSG and with our service SSG product database. Our database is in this structure. We have our items, we have our suppliers, plants, manufacturers connected to this item. And on this item, we have information about part description, GBM, which is our SSD classification tree. We can have our assets, we have the connected brand to this item, and therefore also we have 3 other classification trees at the moment, which is E-class, which is a big European one. We have ETIM, which is for electrical and piping, and we have UN SPSC, which is the UN classification tree. So therefore, in this test, we were thinking about getting Seafulls as a 5th classification tree in the SSG product database. Our structure for the items is we have some sort of identification. In this one, we have our SSG article number, a 7-digit article number which have no logic at all. We have our item designation, which consists of a part description, a brand, and a reference. And on all the items that has a SSG article number, we also have our own classification, which is called GVM. It is a 10-level, top-level system, classification tree down to the 6th level on each starting row. The manual brand item we have in our tree, we connect of brands, GVM, assets, and so forth. So on the items, we have our brand logos, we have a primary product image, we have the brand, the GVM classification, the part description, and article numbers, type designators, and so forth. And if we will further on the SSG classification, is the brand, the GVM, and the part description. And also on each item, we can put, for example, E-class. And on this one, the centrifugal pumps, which are from the templates. We have the centrifugal pump with shaft sealing and those attributes on that. This is already exists in the system. Therefore, why I'm showing this and not the CFOS, because the proof of concept is going to be on E-class and not on CFOS. And if we would have CFOS as a classification tree, it would like this. You have the centrifugal pump with its attributes, and the attributes ID, and the attributes information. And this is how it would look in the system if we have done CFOS in the system. Now I'm going to show you how it's the templates, as Eric has shown you, for one of the items when we take that into the system. On this one, I have done using the E-class identification instead of CFOS, because E-class already exists in the system. That's why the proof of concept is on E-class. On this one, on this row 4, we have the type designation for the pump. You have the serial number, temperature, wheel diameter, maximum flow, effect, how the wheel on the pump is working. So this is the template that SEIIA has at the moment. So we can take in those attributes as E-class. And if we look at this pump, this is how it looks in the system. The brand, image, brand, the GVM, the part description, the type designation. And there, if we look at the reference and classification, we have the SSD classification, as I told you before. So if we go to the E-class tree, the centrifugal pump with the shaft sealing, it's empty at the moment. And if I use the system to import the data, I can do import. I can create a new import, choose which file I want to use. Use the pump file. Do the next. It finds the columns. I can auto map it, or I can map each column by itself to each attributes I want to map it to. But I have done a preparation, so I do an import. I use an existing import. I choose which import that I want to use. I have import E-class, which have prepared the columns. I can do next. I choose the file that I want to work from. It finds the columns, and if we look again at the templates, find the exact same columns in here. I have done the auto mapping, so it finds these E-class numbers, object number, manufacturer, installed, and things like that. Next, object number, finish, do the import. I'm done. As you see, it's empty. The refresh button because due to the import. And now the system has taken in the information that I want to. Sulzer, special open, design temperature, the travel wheels diameter, maximum feed flow, power requirement of the pump. That's it. So if you use these templates which are finished and we have CFOS in our system and we get the information, we can automatically map from these templates to get technical data on each object in the system. Therefore, CFOS is very good for using to import data and use as an interoperability system between systems and other customers. Thank you.
Thank you, Patrick. We have now seen the pump specification that we have worked with in this pilot, in this SEIIA pilot based on CFOS. And when we send this template to one of the biggest EPCs in Sweden, we got this answer that they, in principle, they could have an automatic export of data into this type of templates without so much work for them. So they find it very interesting to that, but the result we have come to in this pilot. And we also sent them a question about the DEXP format, and they also said that they have systems that could export to DEXP. So that's also very interesting to hear from a big EPC in Sweden. So that's why the SEIIA board have decided on the board meeting in the end of 2020 that we should, as an organization, set up CFOS templates in Sweden for helping Swedish industry to achieve a better interoperability and handover process. And that type templates this is a working example of that type of template now when we have worked with it a little bit more. So this is what you see now in the green field is the functional parts of a pump specification. And if you go to the right in this template, you will also find the equipment, the component parts of the pump's equipment specification, and the pump specification, I would say. And then I'll leave the word to Magnus to make the conclusion for SEIIA on this pilot that we've done together. Welcome, Magnus.
Yes, thank you. We believe that using a standard, it will be easier to motivate suppliers to fill in the asset information at the right place in the templates that we have. So we think that the standard would create a better information delivery, which means enhanced quality and less mistypings in the templates. And that would, of course, imply that the interface between the supplier and the customer will be much clearer. And there will be time savings for both parties. And in all, we believe that this would contribute to a better relation between the supplier and the customer. There will be less errors and in that way a better relationship. This kind of standardization would also make it easier for us to compare different solutions. And for example, we could have quotes made semi-automatic. And we believe that it could be relevant to include this also in the SSG delivery contract. However, there will probably be some challenges also with CIFOS in order to implement it. There are several actors that need to accept this standard, and these actors also need to put energy on the implementation. So how big workload it would be to introduce the standard will, of course, determine the success of this implementation also. Of course, there is a quite big workload to go through all the different components and attributes and so on for everything that we have and that is needed when you are installing some new machines. But to conclude, we think that this is something that is very interesting and relevant for the future. Standardization means that we can have a more efficient possibility to handle the information about assets. So I will end with that. Thank you.
Thank you, pilot number 2, SEIIA. We got some questions here.
Oh yes, the first one. In the introduction phase, we could not hear the names of the 2 moderators. Hey, it's you and me. Okay, one guy. Hey, Love. Mats, nice to meet you. Yes. And here we have the whole Europe here with and some Americans also too. Nice.
Very interesting to. Here we have some new voices in the audience. By the way, my name is Mats Larsson, a member of the board of SEIIA, here representing the board today. And to help me out through this event,
yes,
I got my beautiful colleague,
Love Melander. And I'm at the board of Sundsvall here, the head capital of the northern part of Sweden, as we finally say. Yeah.
Yes, and that takes us back to more questions. Yes. I have some quite technical questions, and I want to call in some help. Can we get into the broadcast, Thomas Åberg? Can we get him in?
Hello. Can you hear me?
Hello, Thomas. Welcome.
Thank you.
Yes. Nice presentation you did.
Up to my best ability.
Yeah, that was really good. I have some questions. Does it mean if I want to use GeForce and SiteBase, do I need to be a C developer, C programmer? My idea is that the guy who put this question is it too technical to use the GeForce together with SiteBase? I guess.
Yeah, and the answer would be yes, in the case that you want to develop your own import script and tooling between GeForce and SiteBase. And if you don't want to use any other tooling like Python programming or PowerShell or whatever you can think of to make this glue kit between GeForce Excel sheet and the SiteBase web API and database. But generally, no, because we have to make some tooling around this that will be more, quote, user-friendly. But it would be more like, I guess, like the user configuration I showed in the presentation, where you have a form and you specify the CFOS unique ID and some temporary name that will be sent into the site-based web API and database, like this beskriven I showed in the presentation.
Yes.
And we would if we do a more complete user-friendly tooling, we would also have to set up range of these temporary variables that will go to specific fields in the database later on.
Do I understand you correct that if I'm the end user of a site-based database, in the future I can just get an extra option to work with the SEIIA concept, to make it simple?
Yes, simply put, yes, but you will have to. It will be quite a lot of detail mappings, like in the previous presentation. I think the Juhani said it, that you would have to make some kind of framework documents that describes in very much detail all the specific properties that have to and where they have to go and so on.
Yes.
But no, you will not have to be a developer. No.
No. That's good. Another question: what problems do you see with a general template for object based on SEIIA concept?
Well, I don't really see as some specific problems here. It comes to the details, and that we have discussed a little bit now, if you need to be a developer or not and such. But the one thing I guess is that's general is that each participating system vendor will have to make this mappings and tooling from the Excel sheet with the CFOS names and into their specific system.
I think that's correct. But
no, I don't see any general problem.
No, but if we take us back maybe a year ago, what would you say? How much have been developed through these pilots, and what comes out of it? Is it have we managed to, through these pilots, make something that works from a foreign concept that we have adopted to have a product that you can use in your everyday work?
Was that to me?
Yes, that was you, Thomas.
Yeah, well, I wouldn't say it's a product that you can use generally, because I mean, this is a specific use case, and we just made a proof of concept that works for this specific case. So, but I mean, I think as a proof of concept, it shows enough that this is something to build on. And now that SEIIA have decided to take this concept further and do more pilots and such, I think this is a viable way of going forward.
Yeah. Thank you so much, Thomas.
Yes, thank you very much, because now we're heading down to the presentation pilot number 3. Yes, we call them co-pilots. Yeah.
Excuse me, but you had one more question, I think.
Really? Can we forward up, because we can just we just have.
I cannot see that right now.
Someone have asked, have Excel templates a future? And at least the other participants from this pilot might have the say also. But from my view, I think yes, Excel will not die so easily. It's if you talk to people who are not developers, they will say Excel is the way.
Yeah, thank you for that clarifying on that question. Now I've seen that also. Yeah, but then a big thank you to you, Thomas, and that takes us on to the next pilot.
Yes,
that way.
Back in SEIIA, I hope they are really on the run. I mean, we need some tempo here now. So it's so interesting that when it's like a lay person to try to listen to all this. It's a lot of information. So I mean, if you feel tired a bit, step up and move a little bit, because here comes
pilot Number 3.
Yes.
Walk-in and chief of concept.
And now it's time for make a presentation of the walk-in pilot based on CFOS. When we set up this pilot, we have a rather ambitious plan for it. But now when we look at it afterwards, we could see that much of our time had been to really learn about CFOS and see how it could be used. But if we look at the deliverables that we have reached, the knowledge about CFOS have increased a lot, and I think we have a good experience of this pilot in total. This picture I have seen also in the SEIIA presentation. But as we have said before, also Vakin have their Excel templates for exchange of information in their projects. And in this pilot, we have tried to use that standard template and make it CFOS compliant with CFOS references instead. And now we'll hand over to Walter and Niklas for them to present what their experience of this pilot have been. So welcome, Walter and Niklas.
Hi, my name is Walter. Me and my colleague Niklas will take you through this presentation from Vakin. Vakin is a municipality-owned company serving the owners Umeå, Vindeln, and since January also Nordmaling with water, wastewater treatment, waste handling and recycling. Last year's turnover was 153.7 million crowns with a zero result. As you can see, Umeå are the dominant owner with 90% and around 5% for the other two. The project had a focus at the water sector. As you can see, we have a fair amount of facilities and pipes to look after and maintain. I will now hand over to Niklas, who will take the presentation of the project and the approach.
The aim for Vakin in LCDM Phase 2 was to get further knowledge about the CFOS method and look into how it can be used to improve data management within our projects. As a first step, we spent time looking into the method and learning what it is used for and the benefits of it. Then, with this knowledge in mind, we then looked into our present situation of dealing with plant data and plant information. Then we chose one specific part of the information chain and made a deeper investigation about the possibilities of using the CFOS methodology. And then finally, we spent time talking about the future possibilities of work. There are two main paths in our present project deliveries: to feed the maintenance system EIDUS and to provide our internal customer with information needed for operations and maintenance. The maintenance system EIDUS is mainly used to store a selection of technical data for the installed equipment and for administration of preventive and corrective maintenance. The brick wall on the slide should symbolize that we do not have a connection between the plant register in EIDUS and the project documentation, such as drawings, data sheets, etc. We also need to put a lot of manual work to move information from the project documentation to EIDUS in order to put maintenance planning in place. In order to feed EIDUS, we work with homemade Excel sheets to document equipment and to transfer the data to EIDUS. We have the object listan, which is the base that contains all equipment and is mainly set up during the design phase of a project. As the project proceeds, it is filled with more and more detailed information of installed equipment. For a number of defined equipment classes, such as pumps, etc., we collect more detailed and equipment specific data in the sheet called objektmall. This is also the tool we have used in this LCDM project to investigate a more CFOS-based approach in defining the information we ask for. The next two slides, I'd like to share our experience of our present method for feeding our maintenance system, EIDAS. With a lot of effort in education and training of our consultants and contractors in order to get the information right. We also find the method sensitive, as the reading to EIDAS is based on column orientation rather than the content. We also have a risk for inconsistent data, as much of the input is based on free text fields. We also find it time-consuming for contractors and consultants to fill in. A lot of manual work is needed to get good quality data and the maintenance planning in place. We often also tend to have late data deliveries in our projects. The risk is that equipment is started up without maintenance planning in place.
I will now go through our learnings and prospects from our point of view. What have we learned then? Well, CFOS would give us benefits regarding several areas. The most obvious are standardization, handling of master data, and daily work with the physical assets. But I would like to point out the reduced waste of time. We have an internal estimation that indicates substantial waste due to searching, reconstruction, and physical investigation related to maintenance, production, and possibility to know the installed capacity before a CapEx project. The requirements boil down to decision, manning, and system. Even if our maintenance system has the ability to hold some of the digital information, the system has limitation that tells us that it's not suitable to keep master data, but it's suitable for maintenance of equipment. What prospects do we see? We have identified some obstacles to introduce CFOS, but I would like to highlight the opportunities, in particular the young coming generation, and the benefit of having other companies outside, as you are, and within our business with the same or similar challenges. Implementation of CFOS or any similar life cycle data management system is not a quick fix, but it certainly would fix a lot of today's and the future problems. Thanks for your time.
Thank you for that, pilot number 3 and walk-in. Online here we have from walk-in, Walter. Hello, Walter, can you hear me? Yes, if you look at this pilot, what would you say would be the biggest issues? What have you struggled with?
Well, big issues I wouldn't say, but big learnings, more to say. We realized as we pick up in the presentation that our actual way of working today with the maintenance system would probably have to be changed. So we have more of a look at a master data where we store the object information rather than try to push it into a maintenance system that is more a system for handling errands when we have a malfunction on a specific equipment. So that is mainly the most biggest learning we have, and we're not looking into any supporting system today, but we certainly probably have to, because we have a lot of big projects coming in the pipe for the next 5 to 10 years.
Yeah. Interesting. Thank you very much, Walter. And what you say is what I think is it's all about, is to make these pilots and learn lessons and tell everybody else. Share what you have learned and share your problems. That's how we all together get better.
Yeah, exactly. Thanks.
Yes. So that takes us to the next
Yes,
pilot.
pilot number 4, the last one before we have an amazing lunch.
Yes.
Fermented hearing. Yes, we are in that period. So on pilot 4 we have Holmen.
Yes, and we said welcome to the Holmen pilot. Let's see if we can get in touch with our company.
Now we have come to our 4th pilot at Holmen Iggesund paperboard. When we described this pilot, the idea from the beginning was that we should make an integration between SiteBase and Aveva E3D with a standard solution based on ISO 59226 instead of a traditional point-to-point solution. Participating in this pilot is Holmen, SiteBase and CTEC. And the deliverables in this is to create the integration platform based on international standards. And Amey and Peter are going to show it now. So I say welcome to Amey at Holmen to start this presentation.
Thank you, Eric. I would like to start with a short introduction of Holmen. At Holmen, our business concept is to own and add value to the forest, which can be seen from the various areas we operate in: forestry, paperboard, paper, wood products, and renewable energy. This LCDM project was carried out at the Iggesund mill, which is a part of the paperboard area. Iggesund uses SiteBase as the plant database, from which the information is transferred to our maintenance system IFS as well. Further, we use E3D for our plant model, which is maintained by CTEC. EPCs and consultants deliver parts of the model to CTEC, who then update the whole model. At the same time, they deliver the pipe data and isometric drawings to us. We then import this information to SiteBase. During this manual process of transferring data, there are often delays and some information is lost in transition. When we came to know about the possibilities with interoperability and the various international standards, we were curious to try it out through this project and improve our process. I will now hand over to Peter from SiteBase, who will talk more about the project.
I'm Peter Soltau. I'm an application engineer at Eurocon SiteBase, and I will show you how the link and the integration between E3D and SiteBase works. The situation right now is that Iggesund has its database, SiteBase, at its site, where they have all the project and data, and they have their 3D model in Aveva, everything 3D. It is managed by CTEC. Today they have a manual transfer. That means that all documents and data is then manually put into SiteBase, creating a lot of work, of course. And then from the project database, we go to the plant data database, where they have a digital twin of their plant, and from there the maintenance data is transferred automatically to EFS. We want to remove this manual transfer in this step, so we want standardized data transfer. One of the benefits of this is the standardized data transfer, where we can see that the data is actually getting into SiteBase. Before, when they have this manual transfer, a lot of the data were not transferred at all, or the documents weren't registered correctly either. We want also to secure the data flow and status overview during projects for Iggesund, as they are projects are done in E3D. And from this also we get standardized isometrics. We got a few requirements and conditions in order to create this transfer. We need firstly to find out what data to transfer, of course. Which application is master also is very important. And we need to create a workflow and routines for designers so they can work and do this efficiently. And for that we need to agree on attributes and standardize the approach for all suppliers and contractors so they can work in a similar way and the data is getting in and transferred correctly. So we started with a research phase, started asking what do we need, what information do we want to send over. So we went to ISO 15296 and tried to find out if there's any help there, but we couldn't really find anything that could point us in the right way. And through some SEIIA workshops and information, we got to know a little bit more about SIFOS, and we thought that there are some elements that we can use in here. And we also agreed on that isometric data is the thing that we want to focus on right now. The data that is needed to create an isometric and to transfer that data to SiteBase. So we started from this. We have an isometric drawing, and there we wanted to see what attributes are needed. We matched them to a SiteBase attribute and also to an E3D UDA. That now we were creating those specifically for the solution so we can separate them from other attributes. And we also had the SIFOS number that we could find matching the attribute that we were looking for to see if there are any connections there, and most of them were correct, but there are some missing that we need to look into further in the future. For this we created a new solution. We had a link to PDMS, the predecessor of E3D, but a new solution was created for this, an embedded application based on .NET, and we use SiteBase Web API to communicate with SiteBase database. It's a web service that can access the database with the SiteBase rules. Then the application created in E3D, and the commands that we send create calls to the API. The API, and it turns answers accordingly to the call with a definition and a format set. The definition looks a little bit like this. So we start with data type for SiteBase, and then we match this to the property with a read link, and then we also can have a write link. So the read link reads the information from SiteBase, and we can write back to E3D the write link. But this could, of course, also get the information from a future RDL. It's not something that we have looked into a little bit into this, and there's a few things we need to create this connection, but theoretically we could also get information of what type of object it is, and then the RDL can tell us what information is needed and get that from Sitebase. Other goals that we have for this is to standardize the project deliveries as well for future projects for Holmen-Egersund, so that all suppliers and consultants will follow the same procedure and requirements, so that they deliver as well the data in a way that we can use it. We get a data transfer in a controlled way and a better view of status without direct access to the 3D model. In the future also we want to connect equipment such as pump valves and instruments. We're concentrating on pipes right now. And this will also facilitate operations and manage lifecycle data for Egersund. Now I'm going to show you how the link works in E3D. We have a menu, as you can see here, with all the commands. We can start with single object. We have one pipe, we want to connect it. We'll go to select. And then it starts looking for the pipe based on the name of it and trying to match it to an object in Sitebase. Then when it's finished, it will tell you that the link is not found. The object based on name was found. Finally, we can choose to connect it. Then the element is linked. The pipe is linked to a pipe in Sitebase. What we can do also is, now what we can do then is that we can choose to update the pipe. So in this case, we are updating E3D from Sitebase. You can see marked as well wherever there is a difference between the attributes. Or the other way around is to write from E3D to Sitebase. We can also validate if the element is linked or not. Releasing it will release it. Will release the connection. View in Sitebase will take us to Sitebase Go, our product Sitebase Go, where we can see the pipe online in a web viewer. And there's also the possibility to synchronize, and the synchronize is a little bit more powerful because it lets you choose if you want to go from one side to the other. So from Sitebase to E3D or E3D to Sitebase. So if you, depending on your mark, what you want to link, it will transfer the information there. The data tool that we have will tell us if the attributes is readable in the other side. So if it's grayed out, then we only have a write link, or we only have a read link. We have also the possibility to go to a zone, and it will go and make a list of all the elements inside of the zone. It also works with a collection. And in here we can go and see that one element is linked, but it has some differences. That's why it's yellow. The other one is red. That means it's not connected. So you can go here and either match objects as I did before with one pipe, or I can go select a pipe here. So if I click on that, we'll open a menu. When it's ready. And as you can see, we have search option, so we can go and search for the pipe. You can see we have 3 different options here. You can choose one that fits, and the element will then be connected. And now we can synchronize both of them. If we choose to, or only one of them. If I have both of them and add a few values to synchronize, we mark both, click on synchronize, and 2 elements are updated. As we can see now, in the attribute list, we have a reference, we have a status, and we have some of the attributes transferred. We can go in again and see how it looks. Then we have a few that we have already transferred. Now for the isometrics, we have a similar way of working, where we can go and select one, and we can search as before, or we can also create one. So in this case, it sends a command to the API to create a new document post in Sitebase under the pipe. Like this, and the document is created. Then we can go and update. So we can update the document information. So there's a different set of attributes for this. We also have the possibility to synchronize several documents, same as before. Match them or select them from here. We can also go and alter the revision for one document, or if we are on a zone, we can do the same for several documents. Then when we create a document, we create isometric when all the data is updated. Create one as always, PDF file. We can go and check in the file, and it sends it to Sitebase. That's all from me.
Thank you, Peter. Finally, coming to the learnings from the project, we definitely see a huge potential to improve the quality of the information available and at the same time decrease the lead times. We also feel that it is important for various companies to work together, as most of us face similar problems. Also, after this project, we can confirm that widespread acceptance will take time and hard work. We operate in an industry which has had a low rate of change, but SEIIA is doing a great job of increasing the subject knowledge through various webinars and projects. Thank you for your time.
Yes, thanks for that. And let's hear if we can connect Amaya and Peter. Can you hear us?
Yes, I'm here.
Hello,
Yes.
Hans.
Hello. Good presentation. And what will your opinion be? Consider this project, it's pilot. What potential do you see in forms of time reduction if you implement this in our former project? What can you see in the future? What can we use it for?
Well, it is not only time reduction, but we also get better quality of information. So it is twofold in that way. And the lot of time was spent on matching the various attributes between systems. So we think it is very important that various industries and companies work together to get this matching done. So we don't have to do it for each and every company. It would save a lot of time.
Yes, that's for sure. What do you say, Peter? Do you have any comments?
I agree with Mia. I think that it's very important to have a good understanding what standards you use to shorten the lead. To secure that the information is getting where it's needed for operations. Mainly.
Yes, I also have another question. I'm not sure if you guys can take it, but what's your opinion about the ISO 10303? Are you familiar with that? The step. I think you, Peter. Have you been in touch with that one?
I've been a little bit in touch with it. Yes, it wasn't anything we looked into for this particular project, but I think it's as I mentioned in the presentation as well. We can use any RDL actually to use and communicate with that one, and I think it would be one choice as well to do it in this way. We'll need to look into that and see if it matches all the requirements for Almenningssund, but in that way it could be a solution. Yes.
Yes. You don't have any thoughts about anything that works better or not, or what's give you more possibilities? Comparing this step with the Shifos concept.
Comparing those two, I don't think I have enough knowledge about the STEP project to make a direct comparison. No, sorry.
No, that's fine.
If I might add a little bit from the little knowledge I have about STEP and so on, I think that's more for the mechanical industry when for like automotive, when you make cars and you have detailed structures in that. It's not so much geared for the plant industry, where specifically I think you lack this concept of tagged items. You don't have tag information that much in STEP. And also ISO 15926 is a continuation of STEP concept and further development. And CFOS is also a further development of ISO 926. So it's STEP was a ground, but then it's evolved, and now we are at CFOS, you can say. I don't think it's that suitable to start to go back to STEP at this time.
Yeah, thanks for that, Thomas. Then I want to put a big thanks for the presentation of Pilot 4. And then, Love, what's next? What happened now?
Well, actually, honestly, I'm thinking about technology. Because I think all of you out there have experience. You're sitting in the computer and something has changed in the computer and you haven't touched it. And you're thinking, is it alive or something? I mean, when I was printing out in the morning, suddenly this pops out, this. And I was thinking, is this something more crazy? But actually, it's a font called Surprise. Yeah, and the surprise is that it's time for lunch.
Thank you. Yeah. And then let's go for lunch and see you all together back in 1 o'clock. Thanks for this and see you again.